when we compound interest n times per year, the formula is very similar to the one we've been using. A equals P times the quantity, 1 plus. We take that annual rate and we divide it by the number of times we're going to compound the account. So 1 plus R over N raised to the N times T power, where N, so we're introducing a new parameter, N equals the number of times per year our account is evaluated and interest is paid. So that's important for you to understand. It's the number of times per year that the account is evaluated and interest is paid. So let's talk about how many times that could be. Well, if it's once per year, so if N equals 1, that would be called annually. Annually would be once per year. And you can see if we put a 1 in for N, we're going to end up with the formula that we used in our last problem right here. Now, another way is semi-annually. So semi-annually means twice per year. So they're not going to say twice per year, they might say semi-annually, and that's going to tell us that N equals 2. Another type of compounding is quarterly, and that's when they evaluate your account 4 times per year, because there's 4 quarters in a year. So 4 times per year. So that would be N equals 4. And what would it be if it was monthly? What would N be if it was monthly? N would equal, you probably guessed it, 12. And what if it was weekly? What if they evaluated our account weekly? Well, N would equal 52 weeks in a year. And what if it was daily? If it was daily, then N would equal 365. N would equal 365. So there's some background on the formula and the different examples of what N could be. So in our first example here, $1,000 is placed in a savings account at 10% annum. That means 10% annually. That's your annual interest rate. How much is in the account at the end of 1 year if the interest is compounded once a year and compounded quarterly? So we're going to calculate compounded once a year. That's for N equals 1. And then we're going to calculate compounded quarterly. That's N equals 4. So we're going to look and see, compare what happens if they look at our account more often. $1,000 is placed in a savings account. So that's our principal. Principal is equal to 1,000. Our interest rate, the rate is going to be 10%, which is 0.10 for R. Our time is given to us this time. So at the end of 1 year, that means time is equal to 1. We want to know how much is in the account. So this time what we're looking for is, what is A? So our end amount is unknown. So compounded once a year, let's use the new formula that we just learned. A equals P times 1 plus R over N raised to the NT power. The NT power. A is unknown. P is 1,000. R is 0.10. Compounded once a year means N equals 1. 1 times 1, let me use color here. So this time is right here, and once a year, that's our n. N equals 1 is right here. So you can see that this is going to be the same thing as P times the quantity, 1 plus the rate raised to the T power. So we'll have A equals 1,000 times 1.10. We're going to multiply that out. So go ahead and try and use your calculators. Multiply that, and you should get $1,100.00. So you should get an even $1,100. Now money always goes out 2 decimal places. So 2 decimal places for money. We talked about 3 when it came to the time, but 2 decimals for money always. Okay, excellent. Now let's do this again, saying, well, they're not going to just wait for the whole year to evaluate our account. They're going to evaluate it at the end of every 3 months. So they're going to let it sit there, evaluate it, pay us money 3 months later, let it sit there, pay us money another 3 months later, and we're going to see how much we have at the end of that year. So again, we have A equals P times the quantity, 1 plus R over N raised to the NT power. If you write this formula down, it's one that you'll memorize, and when you take your final exam, you won't have to stress about studying all these formulas because you'll have them memorized. So A equals 1,000 is our principal, 1 plus our interest rate is 10%, and this time we're going to compound quarterly, so N equals 4, raised to the 4 times T power, and that T is at the end of 1 year. So I've got 1,000 times the quantity. Now I'm going to use my calculator. I'm going to put 1 plus 0.01 divided by 4. 1 plus 0.10 divided by 4. Now, in this case, it's going to work out very nicely because it's a decimal that stops, but sometimes it's not. So sometimes I will put all of this, I'll put all of this into my calculator all at once. But right now in this first example, I just want to break it down for you. So I'm going to have 1,000 times 1.025 raised to the 4th power. 1,000, and then you can put parentheses, 1.025 raised to the 4th power. So I'll show you how I'm doing that using my calculator, because the calculator is kind of important here. So you can see that, and then I press enter. And what I was talking about was saying 1,000 parentheses 1 plus and then 0.10 over 4. I put that all in all at once raised to the 4th power because 1 times 4 is 4. And I get $1,103.81. We're only going out 2 decimal places because we're talking about money. So we have $1,103.81. So if we compare the two, the larger N, the more money when P, R, and T are the same. So when the principal, the rate, the interest rate, and the time that you're keeping your money in the account, when those are all the same, the larger the N value, the more money you're going to make. And in this case, you're going to make $3.81 more. And every little bit counts. This next one is going to be a try, and we're going to try 3 different values. And when we come back in the next video, I'm really going to just give you the answers. And then we'll move on to a couple more problems where we're talking about compounding continuous.